Cool beans. Ooh.
Okay, today's video is going to be an introduction to the Fourier series. At the beginning of playlist 9, Tom does a comparison between the Fourier series and the Taylor series. So while the Taylor series uses polynomials of various powers to map out a function, the Fourier series uses trig functions with various frequencies. And then the format for Taylor series is x to the n, but the format for Fourier series is sine of nx cosine nx, etc., etc. Other the form of that would be a to the 0 plus a1 sine x plus b1 cosine x, etc. While the Taylor series is a to the 0 plus a1 x plus a2 x squared. So for that, the Taylor series is better to use locally, while the Fourier series is better to use globally. And you can use it on any periodic function or on any function over an interval. So the basic idea of the Fourier series is to add an infinite sum of trig functions of different frequencies. And the more frequencies that you add, the more that the sums approach something called the square wave function, which Tom uses Desmos to show in the videos. And then 10.5.2 is the Fourier calculation, which is basically an expanded form of what was first introduced in 10.5.1. So that's going to be a to the 0 plus a1 cosine x plus a2 cosine 2x, on and on, plus b1. You use different variables for whether it's sine or cosine. b1 sine x, b2 sine of 2x plus b3 sine of 3x, on and on and on. And all of that equals a to the 0 summation k equals 1 to the n of ak cosine of kx plus the sum of k equals 1 to n of bk sine of kx. And he sort of breaks that down more to finding the actual coefficients of each, like a to the 0, a to the k, b to the k. A to the 0 is going to be your constant term. So that's going to be how much the whole thing should be shifted up or down. And for that, you'd have to find the average value of f of x. So the function for that would be 1 over 2 pi of negative pi to pi of fx dx is what you'd use for that. Then for a to the k, you would, whatever your desired square wave function that you want to get to, you times that function value by the sine value at that point. So if it's a1, then it's going to be the function value times sine of x. If it was a2, then it'd be like function value times sine of 2x, etc. To see how compatible, or he uses the word jive, how well your trig functions jive with the square wave function, your desired square wave function. And all of those are k has to be greater than 0. Then you do the same thing for b of k, but with whatever trig function that you didn't use, if that was cosine or sine, whichever you assign to be with the a variable versus the b variable. So if that value equals 0 that you took of the function value times the trig value at that point, then that means that it's not compatible with your desired square wave function. And that's about all that we've gotten for the Fourier series.
I got a question. So,
Yes,
in that formula, we're supposed to add cosine terms and sine terms?
I think so.
I guess I
Well, that's
understood it
something.
wrong because I thought it was like you can either choose to have a bunch of cosine terms or you choose to add a bunch of sine terms. Like, it depends on what the function is. But I guess it looks like you're supposed, for any Fourier series, they consist of like infinite number of sine and infinite number of cosine terms.
It seems so from at least everything that I got in the video.
Yeah,
Yeah.
looks like it. Yeah. I mean,
Oh, do you
cool.
want to
Anyone
move on
else
to
have
the?
questions, or should we
Yeah,
try to
yeah,
move
yeah.
on to the discussion?
Wait, so how do you add the infinite number of sine and cosines when you're doing like the listed out version of the series?
So like if you mean like for wait a minute, I don't know if this is helpful at all. Like this first part right here, this like a to the 0, that's gonna be your
Yeah,
constant term. And
yeah.
like a
I
to
guess I was just
whatever
kind of
number,
yeah. I was kind of
you would
confused as to how that would work.
Well, it's just kind of like a series. You have to use like the, I don't know if there's a formula. What you can, I think the most you can do is figure out if it converges or diverges. But there's usually, like from before, that's all. Like before we move it into this section, like all we could really do with the series is figure out if it converges or diverges. But if you want to figure out the exact value that it converges, you need like specific formula.
Mm.
And I don't know. I don't think, and they haven't told us a formula for how to like actually calculate the value of convergence. But perhaps if you use like ratio tests, you can find like the range of the interval of convergence. But I don't know if we can find the exact value.
Right.
I don't know.
Yeah, because we only know how to find like the coefficients at this point.
Yeah. That's all we know how to do so far. Yep. Cool.
Right? So you want to move on to our
Yeah.
problem.
hmm
So define a different square wave describing words that only uses cosine terms.
Let's see. So when he showed the
Being like,
when he showed the sine terms,
hmm
um, it lined up with the function, like in terms of the the sign. So in his video, what is his red function? It's just like lines.
oh, the lines that were like this.
Yeah, the lines
I
that were
think
straight. Those were just straight lines.
I think those are supposed to be like the bare bones of like the square wave function, the desired square wave function.
The square root function?
A square wave.
Square wave? Oh, okay.
Yeah.
Okay. So I guess a square wave that only uses cosine terms. Well, there needs to be I don't know how to answer this. Like there needs to
Right,
be
because
like a horizontal
graphically it would
shift
be like the
because
easiest way.
the sign of the cosine function doesn't always line up with the sign of the square wave. So like at some points, at some x values, the cosine function can be positive, but the square wave is negative. So they sort of cancel each other out. Whereas when there was just the sign, it, it's always just negative multiplied by negative or positive multiplied by positive. So it's always positive.
Wait, if you want a horizontal shift, if you do like sine of x plus 1 plus 2 or something like that, then there's a horizontal shift there.
There'll be a vertical shift view. Wait,
No, it's horizontal.
Inside the parentheses?
Yeah.
Yeah.
Like just like whatever a sum
So
of cosine functions with the frequencies that if multiplied by like the desired square wave function, the integral is positive.
I'm sorry.
Right?
Say that again.
Question mark. So like whatever it would be like the cosine functions of such frequencies that when multiplied by whatever desired square wave function, that integral would be positive.
Are you saying? I'm not quite understanding what the
Like,
question.
you know how in the video he was like, okay, you want to find like over a certain interval what that integral would be if you multiply the function times the trig function, and you want it to be positive, not zero.
Yeah, I think you want it to be positive.
Yeah.
Yeah.
So like whatever, wouldn't it just be like the same but with cosine? So like whatever
Yeah,
function.
I think it's the same goal, but because cosine doesn't align correctly, it doesn't achieve that.
Oh, so you're saying that's when you're talking about the shift, or how you'd have to have a shift in it, right, Alex?
Yeah. Yeah. Like the right answer to this question is I'm just kind of like guessing what he's looking for. But yeah.
What question are you guys working on?
So he says the square wave I used in the examples only used sine terms. Define a different square wave. Describe in words that only uses cosine terms. So we're not sure what he's looking for here.
Wait, couldn't it be the same with sine instead of cosine and it just be shifted?
Yeah, that's what I'm thinking. It's just if
Yeah.
you just shift this cosine, it will look like the sine.
Well, yeah, I think the shift is correct, but how much you shift is interesting, right? I mean, like Will, we kind of talked about something similar to this with Taylor series, right? Which is the difference between constructing a function with a series where all of the parts of your series are even functions or the parts of your series are odd functions, right? And what the end result looks like. So if you construct a function out of only even functions, the end result has to be even, right?
Uh-huh.
And if you construct a function out of only odd functions, then the end result has to be odd. So I think with that, you should be able to say something about what the final square wave looks like.
Oh, okay. So that means, so since cosine is even, then the square wave of cosine would also be even.
Right.
Is that it?
Yeah, that's pretty much it. I mean,
all it's looking
from
for?
there, like, what does an even square wave look like? But that's a pretty straightforward step, I think.
Okay.
Do you guys all know what I mean when I'm talking about even and odd functions?
Mhm.
Great. Yeah.
Oh, cool.
Alrighty.